Okay, let me just start by introducing myself. My name is Chungha Wu, and I'm currently doing a master's degree in electrical engineering in Konkuk University. And I'm honored to participate in this EIA conference poster session about power system part. The topic of today's presentation is a different kind of control method using the reinforcement learning. Especially, I'd like to talk about D-STACCOM control by using DDPG algorithm. So with the increased use of power electronic for AC to DC converters, electrical distribution systems are experiencing an increase in nonlinear loads. These nonlinear loads, such as the classical rectifier, have a deleterious impact on the power quality of the modern AC distribution system. Especially the integration of energy resource with the distribution power grid can further deteriorate the harmonic power issues. The matters concerning the system's power quality should be power factor degradation and harmonic current introduction and instantaneous voltage drop and voltage imbalance. So FACS facilities have recently been researched to compensate for this power quality problem. And in particular, D-STACCOM is a compensating device that is used to control the flow of reactive power in the distribution systems to enhance power on voltage stability. So at this slide, I should show you the D-STACCOM topology. And D-STACCOM mainly consists of an inverter connected to the network through a transformer and capacitor C, which provide DC link voltage. So in detail, D-STACCOM should include a detailed representation of IGBT of power electronic IGBT converters, and it is used to regulate voltage on the distribution network like this. So this D-STACCOM actually regulates accent bus voltage by absorbing or generating reactive power. So in this D-STACCOM, this link capacitors like here operates either inductance or capacitance under the certain conditions. And when bus voltage is lower than reference voltage at this D-STACCOM, it acts as a capacitor to inject negative reactive power into the grid. In contrast, when bus voltage is higher than reference voltage at this D-STACCOM, and it acts as inductance to inject positive reactive power into the grid. So both voltage and current components obtained from ABC to DQ transformations in the synchronous reference determined by sine or cosine terms provided by the page-locked loop PLL. And it is then regulated with two separate PI regulators with respect to the reference D-axis and Q-axis currents obtained earlier. So furthermore, the RC damped filters are connected at the inverter output, and a capacitor is acting as a DC source for the inverter. And in this figure, so there are four PI controllers exist, and it shows there are two current regulation loop. So in addition, since our goal is the DDPG algorithm's action vectors is injected to the place of reference instead of real one, the rectangle colored by the red line is the position where fake reference is injected by reinforcement learning. And now I want to talk about three kinds of machine learning. So first one is supervised learning. And it is the machine learning task of learning a function that maps input to the output based on example, like input-output pairs. So it infers a function from labeled training data consisting of a set of training examples. So in supervised learning, each example is a pair consisting of an input object and a desired output value. So like this. So, and in contrast, unsupervised learning is a type of algorithm that learns patterns from untagged data. So the hope is that through mimicry, the machine is forced to build a compact internal representation of its words and then generate imaginative content. So in contrast to supervised learning, where data is tagged by human, like as car or building or bus or like that. So but reinforcement learning has something special compared to the others. So that is it doesn't need a data set. So it is an area of machine learning is concerned with how intelligent agents ought to take actions in an environment in order to maximize the cumulative reward. So reinforcement learning differs from supervised learning or like that. Differs from supervised learning in not needing labeled input-output pairs be presented, and in not needing suboptimal actions to be explicitly corrected. Instead, like they focus on finding a balance between exploration and exploitation by setting the noise vector and or like discount factor. Next, I will explain the 5 basic elements of reinforcement learning in this paper. Actually, like all reinforcement learning, including like Q-running and DDPG and DQM, have the same common. So like 5 basic elements as same as other reinforcement learning has. So first, the first thing I will explain is agent. A reinforcement learning agent takes state and reward and return the actions like that. So the policy is a way to maximize expected cumulative reward. And the main point is agent is role as the brain of reinforcement learning. The second thing is I will explain it is environment. So like here. So in this proposed method, IEEE 13 bus real unbalanced distribution network is conducted to base case study. So this DSTATCOM is installed parallel to the bus 632, and the designated value of this link capacitor used in this study is like 10,000 microfarad, and in addition, like this link voltage reference is set at like 3,000 volts. So the goal is to prove that the proposed approach develops bus voltage control performance with an improved transient response. The third thing I will explain is state, and the observation of other system plays a vital role since it is a core of agent, which enables agent to receive the result from the action and the environment changes. So thus, in order to reflect the same effect on the running system, it is necessary to normalize data to 0 to 1 range. And then, like as you see in the state vector forms like here, composing of 4 observations. And I feel you might be familiar with these forms because it is just meaning of PI terms. So the idea about composition of our state component originates from the input of PI controller that creates a proportional and integral term from the error generated by the difference between the measurement and the reference like here. So you can see the VAC difference like kind of that. And then like I want to say is the next is Liouville vector as a Liouville function, and the Liouville function being an essential part of the MDP definitions and it can be solved as ranking various proposal behaviors. It also can be very user-defined area, and if you experience any matters in running agent, you should handle this Liouville function at the first time you face a problem. The last one is action, and it is the return from agent by using information about the state and reward. So it's here part. And next, I'd like to show more about a deep deterministic policy gradient, like DDPG algorithm more. So DDPG is a model free of policy algorithm for learning continuous actions. So DDPG consists of 2 ideas from DPG and DQN. So It used experience play, which enables other agents to memorize a past experience and frozen target network, and which can operate over continuous action space. So DDPG algorithm uses two networks named actor and creating network. So when you want to design the model, like you should set the parameters respectively, as there are two networks. So actor network proposes an action in given a state, and creating network predicts if the action is good or bad according to the given state and action. And those equations illustrate how the DDPG network parameter is updated by each step. And the schematic diagram of DDPG algorithm is illustrated in this figure. So it seems like environment with IEEE 13 bus, which means like yeah, our experiment in this paper. So the goal is to prove that the proposed approach develops bus voltage control performance with an improved transient response. The system profile shown in the figure left side is used to evaluate that performance in various conditions. Since bus 650 is slackless, which means main feeder, IEEE 13 distribution system is connected to main grid through bus 650. The transformer is connected between like 633 to 644 bus, and yeah, it looks like that. And so data of line impedance and system informations are referenced in the IEEE 13 bus system. So voltage source at bus 650 is variable that designated in programming, and it fluctuates between 0.99 and 1.01 as shown in this figure. Experiment has proceeded on the assumption that this STATCOM is installed in parallel to bus 632. And so we want to check in this scenario is how this STATCOM is well controlled when the main feeder's voltage here are changed compared to conventional control design. So in this scenario, both conventional method and DDPG approach guarantees voltage stability through reactive power control, which means current transient response is improved, and in the control system, setting time which required by the response to reach and steady state within specified range of 2% to 5% of its final value is the crucial criteria in determining control performance. This figure shows the current comparison between the DDPG approach and conventional method. As the slack bus voltage changes from 1 to 0.99 at 0.2 seconds, like you should check the DDPG approach. It takes like more faster to reach a steady state. Like, and other cases also act the same as like here. So, and as we've seen this, so does DDPG approach to make a variable reference is positively like influence the performance and setting time. So as you see in this figure, like the waveform is way faster to converge to the steady state as compared to between DDPG approach and conventional method. So like you can check the waveform is more like when we use the DDPG approach, like yeah, it says like the or here like so it can check the transient performance is improved. And the real reference of this STATCOM is set at 1 PU, which means like 4.16 kilovoltage at real voltage, and which is shown as a blue line in this figure. And in figure, it shows that the DDPG approach returns action vector as a variable fake reference when the programmable voltage source is changed. Applying the DDPG approach into control system, reactive power is also converged faster than conventional method. So in this, voltage transient response is enhanced since reactive power output of D-STACCOM converged faster. So in addition, so you can see the reactive power in each page are, those are depicted in the left side figure. The response characteristic with and without this D-STACCOM are shown in right side figure, and the figure shows that specific value is near 1 and not be controlled when without the D-STACCOM. So the purple line is like without the D-STACCOM. Besides, the transient response is enhanced when the back reference control method is applied in comparison with existing control theory. So this confirms that model works adaptively with programmable voltage source that indicates variable power system conditions. So this part is a conclusion of my presentation. So the proposed model makes phase reference to control both voltage while reinforcement learning instead of real reference what exactly desired by control designer. So what we want to say is even though control designer want to set voltage at 1 pu, reference should be changes to enhance control performance. So in a further study, more case studies considering the variable AC voltage reference of this D-STACCOM and LPF problem with other fax device will proceed together. And that's reference. And thank you for listening. And I conclude my presentation. And if you have any questions, just let me know.